My name is Benjamin Cabé. I am a developer advocate at the Linux Foundation for the Zephyr project. And today we're going to talk about SBOM software bill of materials, what it is, how you can use them with Zephyr. Being a developer advocate, I guess, I'm by no means a lawyer, by no means an expert on the topic of like software supply chain management, but that's almost kind of the point of the presentation. We hear a lot these days about like software, like tracking software provenance and those kind of things. This is becoming increasingly important, especially in the context of embedded devices. And I wanted to learn more, quite frankly, about the topic, figure out what sort of the landscape of the tools that are available out there to help with that, basically. And by that I mean what is an SBOM in the first place, why you should care, what makes it even more important to have a sense of like what is your bill of material software-wise when it comes to embedded, what are some of the tools, standards out there. SPDX is one that you may have heard of. What does it mean for Zephyr? Like, are there things available that can help sort of capture the SBOM, and we will see what an SBOM is in the first place. What are some of the tools, and hopefully some time for Q&A as well. I mean, some of you, many of you, most of you, I don't know, you are embedded developers one way or the other. A BOM you're familiar with, sort of like tracking and capturing the list of all the things that physically end up making up your PCB and your actual device. That's great, and I mean, you need that, and I mean, actually some regulation authorities might actually be interested in that. Kind of similarly, frankly, you want that for your software as well. This sort of like nutrition facts kind of label and list of what are all the things that I'm pulling when I'm running West build for my Zephyr application, what ends up being shipped, being put in the ceilings of whatever buildings where I'm deploying remote and like wireless thermostats, what is ending up in cars, medical devices and whatnot. Like, it's important for many reasons which we will dive into, but they all boil down to understanding basically what is the kind of software that you're sourcing and shipping into your actual products, and basically managing your supply chain for the software as well. There's many reasons why you need to basically extend the and to look into what kind of software you're shipping. It kind of starts with, frankly, for legal reasons and licensing reasons. Like, you might not be able to use necessarily all the kind of software that you wish. Like, there might be some open source software, open source projects out there that you would love to use, but they are basically just incompatible with either other open source software that you're already using, or just incompatible with your product strategy or your company's policy. So basically helping you understand what it is that you're pulling when you're sourcing open source component A, what are all of the other dependencies that are not necessarily super visible at first, so that you can realize that, oh yeah, I thought A was okay, but there is this dependency that will actually be problematic. Or also, decision-making wise, having more visibility into your sort of dependency graph will also help you maybe design your software better, because you will sort of think twice when it comes to just like very conveniently taking this random project off of GitHub and figuring out that at the end of the day, although the license was kind of okay, it kind of pulled many other dependencies that might sort of bite you later on. So getting more visibility, more insights into the kind of things that you will be sourcing and eventually putting in your final image is quite important. Frankly, there's also reasons that are basically just you're shipping a product, and the FCC or the Cyber Resiliency Act in Europe and whatever new regulations might come, existing or new regulations, actually ask you, although it might not be like required that you make that available publicly to your end customers, They might ask you that you actually keep track somewhere in your technical documentation of a high-level list of what are the components, what are the suppliers of the software components that you ended up putting into your product. Of course, one other important aspect is you want to know what software you're using, also to get better visibility in terms of, am I impacted by a security vulnerability? I mean, I kind of know that I've been using embed TLS, say, for like securing my networking stack. There's apparently a vulnerability in version XYZ. What's the version I was using again in this product I shipped 18 months ago? Hopefully, I mean, it might be, depending on how you've been sort of, what are your internal processes, it might not be that easy to get that information quickly so that you can really react and potentially patch your devices, etc. if you're impacted. If you're not, you also want to know that because you don't want to patch and roll out like painful, risky software updates in the field if you weren't impacted in the first place. And this kind of also boils down to having and using, hopefully, not only like thinking about materializing this software bill of material, but also doing so using existing tools and standards so that you can really streamline the process, and it's not only, it doesn't become an afterthought, but it's really something that just like taps right into your development best practices, taps into like, or hopefully using standards, also taps into other tools that the software regulation authorities and the government regulation authorities and whatnot might require you to produce. Like when you're expected to give an SBOM to, again, say FCC or the European Commission, they will ask for a given set of information. You'd rather use standard tools for that. SBOMs, so it's not necessarily a new thing, obviously, but interestingly, when it comes to embedded, there are things that make it even more important / tricky to address. Like in embedded, I mean, and I guess in many other places, but in embedded, there's often like a really good mix of open source and proprietary software. So tracking and sort of identifying what is what can be quite important. The way to build embedded software, there's actually many ways to do so, and there might be different pieces of your application that are built in different ways. So all those different pieces and compilers and tool chains and whatnot, like, are they able to give you the information, the metadata you need to really capture like all the things that you would hope to get into your SBOM? There's all the constraints around longevity, like embedded products, connected products, IoT products, they get deployed and run for a long time, which means that this particular SBOM that captures which version of embed TLS you were using and which tools, which compilers you were using to build your solution. It's really, really important to get accurate information and across the entire supply chain, which is, if we think Zephyr, but really any embedded project, really, there's lots of pieces, lots of software components that you're pulling, right? Like there's probably HALs from your silicon vendors, there's the RTOS bits, there's third-party modules, like I mentioned, embed TLS, could be TensorFlow Lite, I mean, you name it. There's your own code, right? Like it might be released under whatever license, it might be, yeah, whatever really, but it can be complex. So there's a need to, I mean, and there are standards, hopefully, out there to sort of standardize what should go into an SBOM, what's sort of like the minimal required set of things, and again, metadata that you need to capture to identify the provenance of your software, all things licensing, security informations, like things that identify the software components in a good enough fashion so that you know whether such or such module, when there is a CVE reported, is this the actual module that you're shipping or a version that is impacted by a said vulnerability. So yeah, SPDX is effectively an ISO standard. If if you're familiar with the topic, at least remotely, you may have seen that there is a brand new version of SPDX that was released over the weekend, I think, and we will be briefly touching upon that. What is SPDX? How does it look like? It's so SPDX, it should really say up there. So you will see the typo for the next couple of slides, I guess. So it's you may have heard the term, frankly, just because you're a contributor to open source, and there's always those headers, copyright headers or license headers that mention the standard. There's more things that go into the standard in the form of basically standardizing a manifest for, say, if I were to build this open source or whatever, really, this application made of really only a simple source file, a make file that provides probably some kind of instructions to build the system, and then a binary with SPDX, and without like, we won't read everything line per line, but splitting all the entire content of like the manifest for the hello package / application that eventually might go into an actual product would look something along those lines. Like you would have a set of like keys and values that go into the file, identifying who created the package in the first place, who created the manifest also. It might be you might have been relying on a third-party tool to help you with providing some of the information in there. Where can one find, like, where's sort of the origin of the software, of this particular software package? In this case, looks like it comes from GitHub. What is the SHA of the commit corresponding to the version of the application / package? What's the license that is provided by the provider of the package, either through like documentation, or either through, it might be something that the tool has automatically guessed based on other information. So this is something that can be materialized in the SPDX file. What is the actual binary corresponding to the application? Again, it probably has some kind of hash and signature that can prove useful to check later that the package hasn't been tampered with. What are the source files? What is the license, the copyright information of the source file? I think you get the idea, right? Capturing also the relationship between all those elements. The source file gets touched and gets manipulated through the make file, so that it eventually generates a binary. I mean, all those kind of dependencies. Again, you get the idea. This is how you're eventually going to capture the kind of information that will be useful to know. Oh yeah, like someone just told me that this source file in embed TLS in version XYZ is problematic. Is it part of my build? Is it part of my package? You can get that kind of information. How do you build the SPDX file? There's tools out there, and it can be, some of it may be done manually. I don't think that makes sense when it's like, when we're talking like hundreds of compilation units and tons of like license information, etc. So obviously there's tools that help automating that. In the context of Zephyr, actually, there is a support for SPDX. Not SPDX 3 just yet, so we're looking and talking about SPDX 2.3 at the moment. But the way it works is pretty simple. As an end user or a consumer of this functionality, you just ask West, the West meta tool, to generate an SPDX for you. And so it's kind of like a three-stage process. First, when initializing prior to building, you sort of want to give a hint to West and to CMake under the hood that you want to instrument your build. So the reason it's opt-in is basically because it might slow down your build just a little bit. It's basically going to use CMake API. Like, we are telling CMake ahead of time, I want you to give me lots of like information with regards to what are all the compilation units that are going to be pulled into my build. What are their dependencies, whether they come from Git or something else. I mean, there's quite a nice API actually that West is going to use or is going to tell CMake to enable. Then we build the project as usual with, again, an extra option that gives even more metadata to capture even more metadata. I guess, actually, I just said something wrong just before, like for example, identifying whether something comes from Git or not. This wouldn't be CMake that does that. This is actually West. So enabling the build output meta thingy, this is the kind of thing you need to know what are the modules that your application might be using. Modules as in Zephyr modules. Zephyr modules potentially mapping to modules in the context of CVEs, like CVEs are reported against embed TLS, against tiny DTLS, whatever. And so once we have basically our build, all our artifacts, plus all the metadata, then we can just compute and spit out an SBOM. 3, actually. 3 and soon 4. It's the way, I mean, yeah, it's split across 3 files, but essentially this is sort of the same information that you get. In one file, you would get all the, something that's more like related to the actual sources of Zephyr, and the one out of the thousands and thousands of files that make up Zephyr, there's probably only a handful or maybe 100, I don't know, but not only a few that are going to end up linked into your final binary. So what are those sources? What are the file names against, again, the MD5 hash, etc. So the Zephyr.SPDX file captures that. The app.SPDX does about the same, but for your actual main and your own application code. And then the build SPDX is more about the build artifacts, like the final health image, potentially the .a's and sort of like the all the intermediary objects that were built, and again with all the dependencies allowing you to track how such or such library or such or such final image was obtained. And so yeah, that's what you can get for free basically in Zephyr. And we're going to see sort of in action what is the information that's captured and how to make sense of it, because I mean that's what you want. There's many things that the SPDX prove useful for. First one, I guess, is if you start caring or being asked about having SBOMs, you better do it in a way that, like, where you're actually capturing as much information as you can. Like it won't help you all that much if the SBOM only tells you the list of all the files that were used for building your application. Sure, it will be still sort of a valid SBOM, but if it doesn't contain like the signature of the files, like the creation date, the origin, as in which repo they were pulled from, etc., then that's not really useful for security management or for anything really. So you want like tools that hopefully help you do that, sort of assess whether your SBOMs are as good as it gets. You want to use the SBOMs, of course, to understand the licenses and what is sort of like your security posture, or I should say, I guess, legal posture when it comes to am I pulling GPL code that I didn't realize I was, things like that. And eventually, or at least on top of that, having the ability to find vulnerabilities, because if you've captured enough information, then you can probably know whether when a new CV is open, whether it sort of matches the kind of information that's in your SBOM. So some of the tools, and that was sort of my long intro into why I wanted to do this talk. I want you to sort of leave the room with some pointers to open source tools that I found pretty useful to make sense out of the SPDX and the SBOMs that you can get out of Zephyr or any other system really. One is the NTIA checker, so that's kind of going in order of the 3 bullet points you were seeing just before. First, looking about sort of completeness, like am I building SBOMs that capture enough and useful information? So there are guidelines from some authorities out there. One is NTIA. I actually forgot what's behind the acronym, but this tool will tell you for a given SPDX file, essentially, whether you are doing all you could. So if I were to, and this will be my call to action at the end of the presentation, the tool in Zephyr, like the SPDX tooling in Zephyr is not perfect just yet, sometimes because the tool itself could be more complete and more powerful, or sometimes because we just don't have enough metadata. The metadata we would need doesn't exist in the first place. So it's kind of a bit of both. But yeah, say we look at the SPDX file for my Zephyr application. Apparently, I've done the right thing when it comes to capturing the names, the identifiers of the components. But one thing that's missing is having notion of the suppliers. And so I guess for something like embed TLS, the supplier would be, I mean, there's probably some standard way to describe that. It's probably the ARM embed TLS contributors, or like it's probably a pointer to the website of the project. But yeah, I mean, this is apparently information that would be useful to capture. So yeah, this tool is interesting in that regard. Kind of related, the SBOM QS tool, SBOM QS as in SBOM quality score. It allows you to assess the quality of the SBOM and how consumable it is. So it goes actually, I think, slightly further. The previous tool was really about like guidelines and recommendations from the authorities. This one is more about like quality in general, and we see similar information, frankly. Do we have names? Do we have identifiers? But it actually gives you a score. So you get to dig and to surface better. Oh, okay, I forgot, I have only like 95% of the supplier information that was provided. What are the 5% that are missing? Like, it's able to provide you with that information, give you the nice scorecard that some project would probably like and want to actually surface in their readmes and whatnot to demonstrate that they've done the right thing. So yeah, that's another tool. This one is kind of like showing it as sort of an anecdote or as an FYI. It's not really going to use the SBOM as in the SBOM of your actual application, like everything I just said before. It's a tool from GitHub that shows you the a SBOM, which rather corresponds to what are the dependencies that are defined or that can be found in your GitHub repo. So for something like Zephyr, there's like lots of lots of Python stuff that we're pulling, for example, as part of the build system or of West, documentation build, whatever. Those are things that you may or may not use, but it's good to know and to have like in just one place a list of the provenance, the versions, etc., etc. That's something that maybe you want to capture whenever you do a release. And so this information is available as well. If you use the GitHub CLI, you can run the SBOM command, but that eventually gives you exactly the same as what you get on the. Oh, I'm not logged in. It might not work. Let's see. Yeah, it depends. Yeah, so that would be the kind of information that you see here. It might not be complete. It might not be reflecting the reality of what eventually ends up in anything, really. Just like some stuff that's part of your infrastructure, and it might make sense to capture that information. Back to the slides. SBOM2 doc. So that's a Python tool, Python helper. This one is quite nice because earlier I was sort of breaking down what goes into an SPDX file, all those key values. It was really flat, right? And it wasn't really surfacing or showing you any form of structure. With the SBOM2 doc tool, you can get a JSON file, a PDF, at Markdown, which is more like the kind of manifest that you would print and give to the authorities as a really like a list of what it is that you're pulling in your system. I think I was running it just before starting the talk. SBOM2 doc for Zephyr SPDX. So out of the 3 SBOMs, this is the one that's sort of listing all the sources that made it into my app. My app here is I built the Wi-Fi sample for an ARM board. So we will see a bunch of ARM stuff, like Zephyr ARM Arch stuff. We will see a bunch of drivers for my particular Atmel board. We will see the kernel, libraries, blah, 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 the network subsystem. And so for all those files, we get the information that's coming from the SBOM, the SPDX file. So license, and this is where we can see that some information is actually missing and could be or should be surfaced there. What are some of the packages that are part of my repo, etc., etc. So that's SBOM to doc. This is where it gets really interesting. So the demo of this one I will show in just a bit, but it's a tool from Intel that looks more at the third, I think, bullet point in my list before, tracking security vulnerabilities. Once you start capturing the list of files that you're putting into your application with their hash, and also potentially the list of modules, which conveniently, I mean, we have a notion of modules in the Zephyr ecosystem, right? Am I shipping modules that are impacted by a vulnerability? And so that's the tool, and we're going to see how it works. I mean, you can use it with the current version of SPDX tooling in Zephyr. It will give you some level of feedback, but it starts really getting interesting when you look at some work that the community is doing around improving SPDX tooling in Zephyr, specifically around adding support for something that's called CPEs and their sort of counterpart, which is pearls. So it's coming from security authorities and like the authorities managing CVEs and so and whatnot. They have standard ways to describe software packages. Something like ARM embed TLS. If you look, if you Google for all the recent CVEs around, say, embed TLS, those that have been disclosed or those that are still in their embargo for what it's worth, as part of all the metadata, like you will have, of course, the description, you will have the score, like telling you how bad of or how risky or how serious of an issue that is. And one of the metadata is the CPE. That's what sort of uniquely identifies the package and the version/version range of that the vulnerability applies to. So CPEs, the syntax is the first bullet point. There is another variant which is called pearls, which is more where it would be pointing to some kind of source control management URL. But that's essentially the same information. And this PR, which I was hoping would have been merged before this talk, but I'm pretty sure it will be merged imminently, proposes to add support in Zephyr to augment the metadata of Zephyr modules with the kind of information that I was just talking about. So in Zephyr, when you basically install Zephyr and you do the initial like West update thingy, it pulls all the modules that are defined and described in your manifest, and all those modules themselves, they have manifests that describe how to build them, how to configure them. The proposition is to add metadata that indicates, oh yeah, the embed TLS module that Zephyr has, it's effectively embed TLS version XYZ. I mean, the sort of the fork we have in Zephyr is usually like pretty much the upstream equivalent to the upstream project. And so capturing that information so that when you then build your SPDX, you create the SPDX file for your application, there's one additional piece of information that's being surfaced, which is, oh yeah, your application is, this is the Wi-Fi sample from Zephyr. Oh, it pulls in TLS. TLS, as per the West metadata information, is in version 3.5.1 in your shipped binary. Then you can just ask this tool, and by the way, I'm showing an open source tool, but I know for a fact that there are some commercial tools out there that are way more powerful and way more sexy also to some extent, and have way more complete databases of vulnerabilities that you can use, but granted that you have captured the CPE, that's what you can do. And that's like really, I'm running that against the proposed PR. Are there any vulnerabilities in my code? Yep, you're shipping MBRTL 3.5.1. There are three vulnerabilities. Some of them seem to actually be reasonably critical. So that's, I think that's where this kind of promise of SBOMs are meant to be the manifest of all the things that end up in your software. That's where it starts really showing its value, right? And something else that's coming, or was just released, like I said, is SPDX 3.0. which the main idea is that, I mean, I've been walking you through some of the data that goes into an SPDX file. It's, as of 2.x, it's pretty flat. It's pretty hard to, if I go back a few slides, basically. The fact that there's some information missing in there, in the current version of the SPDX file that I'm shipping, might not be a problem depending on who you are. Like there's many entities that might be interested in the manifest of a particular binary image or like software. If you're a lawyer, you really don't care all that much as long as the license information is being captured. That's what you're going to care about. If you're someone who is like, I don't know, a release engineer who cares about reproducibility of builds, etc., maybe the kind of metadata that you want to make sure is being captured are things like the like what is capturing the description of what were the artifacts used to actually build the system. So not necessarily the source files, but really more like the make files and the like descriptions of all the compilers, tool chains, and whatnot. So long story short, the idea of SPDX 3.0 is to describe a handful of profiles to cater for like the different kind of consumers or producers, for what it's worth, there might be for an SBOM. Again, if you're a lawyer, if you're interested in all things licensing, then you really care about all things licensing. If you're more you're coming more from a background of, I want to make sure that what we did with AI is like we have been using models that are clear IP-wise, etc. You might care more about some of the metadata that's being introduced by SPDX 3 around all things AI. So yeah, that's basically what I had. As always, help is very much wanted. I don't know much about you guys, but this is where we have time for a quick discussion. If some of you are interested in those in this work around SPDX and SBOMs, SPDX 3 was just released, improving the current tooling that we have in Zephyr so that it's compatible with SPDX 3 would certainly be most welcome. There is, as you saw, still some data that we could capture that we are not, either because the tooling is not complete just yet, or we would just need to add the metadata to whatever files where it's missing at the moment. And yeah, as always, the best way to sort of interact with the community would be GitHub, Discord, to ask any questions you might have or any feedback you might have. But we also have, I think, a few minutes, 5 minutes for questions.
Yes, you got about 5 minutes.
Yeah, cool, perfect.
First, thank you very much.
Thank you.
Do we have any questions?
So all of the tools you've been showing today rely on the presence of SPDX tags, right? Pretty much?
Yes and no. I mean, SPDX tags, if you, like in the Zephyr source code, there's not that many, frankly, right? It's just the license information, copyright information. We're not even using the sort of the standard stuff. It's the licensing information, like I said in the beginning, it's only a subset of of the things that you want to do. And the SPDX tags, as you mentioned them, are mostly related to licensing, but there's also more metadata that just like the kind of thing that you want to capture when you build your application, like the hash of the files or the Git remote URLs of all the modules, etc. You don't need anything special except for the tooling that needs to be built to make sure that you turn this information that you were able to compute into and dump it into the SPDX files.
Yes, but I understand that, but what I mean is in terms of licenses, or providing a list of licenses that the application uses, one of the tools showed a very nice...
Yes, you rely on tags for
that
one, yes.
Is that relying then on the, I don't know if you call it tags, the SPDX line?
Yeah, that relies on the tags, yes.
Okay, all right.
And this is where I think the commercial tools are adding additional value. In SPDX, there's this notion of the concluded license versus whatever is called the other option, which is you always have I mean, sometimes you will have tools that make an educated guess about the license, right. And you can still sometimes override that because you know for a fact that another license applies. Or I guess it would be the other way around. The tag is missing in the file. The concluded license would be none as per the tooling, but then you as a human, you know where this is coming from and you may be able to add this information. But obviously this is way beyond the scope of open source tooling or beyond the scope of what Zephyr provides as infrastructure, right, to help people.
Right, okay, that's the context I wanted to get.
Yeah, okay. Yeah, there was one here.
There's someone up here first.
I think you answered it in the previous question, but the Zephyr build creates the SPDX files that you can then analyze. And it creates those files by basically text parsing the tags that are embedded in those libraries that it pulls from?
Yes. So when you enable and when you're interested in SPDX output as part of your build artifacts, you first ask CMake basically to give you the list of what are all the files that are actually relevant. And then once you have this list of source files, this is where you scan them for license information. And this is where you use also the CMake metadata to figure out what's the dependency between, oh yeah, this source file ended up being this .a, ended up being part of my ELF file. And so then you have all the pieces that are finally together, yeah.
So does the Zephyr meta SPDX application, can that be abstracted out away from Zephyr and then used for any project that uses CMake?
Yes, there's actually a talk which I think is still applicable, the content of the talk. The person who actually wrote the CMake-based black magic stuff for Zephyr gave a talk at FOSDEM, I think in 2021. So you will find both the slides, the video online, or you can just look at the code in Zephyr, how they used. I had no idea that there is a CMake API, right? And so that's basically what it's using under the hood. So yeah.
Thank you.
Hey, Benjamin. So yesterday, Kate was showing all kinds of SPDX variants, SPDX safety, security, licensing, and a whole lot of other things. Take safety, for example. I mean, she was showing traceability, testing, and so on. What does that mean to us, for example, as a Zephyr project, to actually get to that? Does that mean adding all of this metadata into the files, the relevant files? Or is that something that would be...
I think it's similar to what Carles was saying at the beginning. If adding some kind of metadata, I mean, there's no requirement, as far as I can tell, like the SPDX specification is really just about the final manifest. How you obtain it is up to you. If adding some tags helps you achieve that, then that's great. Typically, the tags that we have in all our headers for license and copyright, that makes our lives easier, so we do that. But if we have other ways to capture requirements, traceability, and whatever else we need, I don't think there is any sort of standard tags to do that. It might be, we might have our own YAML files, which we will run through some generators to spit out the SPDX file. Does that make sense?
No, what I'm trying to get to, I mean, right now we have the license tag, which is basically the minimum that probably SPDX can consume in terms of like, metadata. A lot of things are automatically generated and figured out, like hashes and stuff like that, and that's completely fine. What I'm trying to get actually to something intelligent like traceability. By the way, the echo here is so bad, yeah? Yeah. There will be a need to add metadata and identify files and put like all kinds of things. And I'm trying to understand how intrusive that can be the more.
Yeah. I think I get the question.
Yeah.
And my point is that as far as I can tell, there's no tool that expects anything. There's no tool that will take whatever tags you're thinking of and will do anything magically. We will have to write ad hoc tools to generate the SPDX files anyways. So it's whatever we think is convenient for us to describe the information. Like even like all that I've shown, it's relying on ad hoc so-called ZSPDX tooling in Zephyr itself. Like the SPDX files, we generate them manually. It's not like we would use a tool to be like, hey, here's the Zephyr sources. We have put all the traceability tags. Please give us the SPDX. As far as I know, this kind of tool doesn't exist. So we'll talk more.
Yeah. Okay, any other questions?
Thank you very much.
Thank you.